Alright, in this quick little video we're going to look at a couple log problems here, and I'll save this one for last. But if you'll note, in the first three there are three locations for numbers or variables in log expressions, and in the first three examples we take a look at each one of the three locations where a variable may show up, and the other two being numbers. So in this first example, when the variable is at the end, the y in this definition, if you will. Next we'll take a look when the variable is the subscript or the base, and when the variable is this x value from the definition. And then this is a little advanced trick, not super duper advanced, but compared to someone who's never seen logarithms before, maybe a little advanced. Okay, so for all of these, we are going to learn a couple more tricks in the next section, but for all of these, we can pretty much use this definition if we get stuck and rely heavily on this definition. Even when we learn new properties in the next section, this definition we can always fall back if we forget some of the properties. Alright, so first one, r at the end. It's the thing the whole log is set equal to. So we can apply this definition, and I'm going to convert this logarithmic equation into an exponential equation here. So the base, the subscript here in exponential form, is the number 5. The number at the end of the log expression on the other side of the equal sign in exponential form, that is the exponent. So r is the exponent. Then we have our equal sign in exponential form, and then the number at the end of the log is the answer in this form. So that is going to be 125. And when you put it in this form, it's effectively asking, what exponent power do I raise 5 to get 125? You're going to learn some properties very, very soon to solve this explicitly, but for right now you can do a little guessing and checking. 5 squared is 25. 5 raised to the third power, 125. So the only way that this guy could be true is if 5 cubed equals 125. Therefore, r equals 3. So log base 5 of 125 equals 3. This is effectively saying, once again, the exponent power I would have to raise 5 to get 125 is 3. Okay. In this next example here, we have the base in exponential form is the subscript in log form. That is this b value. Okay. The exponent in exponential form is the thing on the other side of the equal sign in log form. So that's going to be 2 equals, and then the answer in exponent form is the number at the end of the log expression in log form. So that's 36. And then this is just normal algebra. Hopefully you realize that to get b alone, we are going to take the square root of both sides. b is going to equal 6. So it would be log base 6 of, oops, I wish I had white out. Log base 6 of 36 equals 2. And just to translate that once again, that's saying the exponent power you would raise 6 to get 36 is 2. Alright, this next guy here the variable is the thing at the end of the log expression. So we'll apply this definition once again. So the base in exponential form is 7. The exponent in exponential form, that is the thing on the other side of the equal sign of the log expression. So the exponent in exponential form is 3, and the answer in exponential form is the number at the end of the log expression, so that's w. And once you convert this one, now it's quite simply, okay, we'll just enter in our calculator 7 cubed. And that is 343, pretty sure. Yes. So W equals 343. Another way of thinking about that is, once again, when you kind of take the answer, substitute it in, and try to make sense of this all, log base 7 of 343 equals 3. That's like saying 7 raised to the exponent power of 3 equals 343. And this last one here, we're going to use a tiny touch of trickery for this last one here. And the reason being, we'll start it off the same way. We will apply this definition and convert this logarithm equation into an exponential equation. So the base is 4, the exponent is r, the answer in exponential form is 8. Now, once again, very soon we're going to learn explicitly how to go ahead and get this exponent value if that is where the variable ends up being. In this first one, we just did a little trial and error. Hopefully you are familiar enough with the power of 4 to realize that this is not going to be a whole number. 4, not 42. 4 squared is 16. 4 to the, not 41, 4 to the first power is just 4. So it's somewhere between 1 and 2. But here is what you can do. You can think of the number 4 and 8 and think about, could we express 4 as a number raised to an exponent power, and can we express 8 as that same number raised to a different exponent power? And if the answer to that question is yes, then here's a little trickery that we can do. So 4 can be thought of as 2 squared, and 8 can be thought of as 2 cubed. So because we can express 4 and 8 in terms of the same base, let's replace these two values into this equation, and we get 2 raised to the power of 2 raised to the power of r equals 2 raised to the power of 3. And now we can use our exponent rules to simplify the left-hand side here. When you have something in parentheses raised to an exponent power, all raised to another exponent, you can multiply the exponent powers. And the only way 2 raised to the 2r would equal 2 raised to the power of 3 is, of course, if 2r equals 3. And then we can divide both sides of this equation by 2. And there is your lovely r value. R equals 3/2. So we make it all the way back up to this original problem. R will, and another way of thinking about that, just to make sure that this makes sense, 4 raised to the power of 3/2 will equal 8. And if that's the answer. But just in case, if you don't believe me, we should always check, because sometimes I make mistakes too. I don't want to get stuff wrong. Oh, good. So the logarithm definition here is of critical importance. These problems can be a little confusing at first, but oftentimes in life, something that looks really confusing, if you practice it and you know what you're doing, maybe it's not as confusing as you may have originally thought it was. This happens often in life, so stick with it, don't give up, and you may actually find it's not as tricky as you thought.